Inshallah, in today's class, we are going to transform the quadratic form of the matrix to canonical form. We say canonical form or sum of the squares form. Canonical form or sum of the squares form. We are having three methods: diagonalization method, orthogonal reduction method, Lagrange's method. Diagonalization method, orthogonal reduction method, and Lagrange's method. The first step, let me see by using diagonalization method. The method is we have to suppose, just I will explain before going to the question. We suppose A equals to I into A into I. Suppose we are having a 3 by 3 matrix. So for instance, suppose 1, 3, 4, 0, 1, 2, 3, 1. Okay, we'll have the same values 4, 4, 2, 5. See here, equals to I into A into I. Now here we have to change the A. First we have to make this two zeros. First we have to make this two zeros using R1. When you use R1 and make this two zeros, we will change this one. We will not change this one. In the next step, we make this two zeros. These two zeros using C1. When you use columns, we will change this identity matrix, but not this one. We change only this one. First step, second step. Then third step is we will make this one 0. To make this to make this 0, we use R2. When you use rows, we change this one, not this one. Then lastly, we have to change this into 0 using C2. When you make this 0, we will change this one. Thus, if we left with only these numbers, this form is called canonical form. Okay, we apply with this y1 square, with this y2 square, with this y3 square. With this, suppose for example, we write 1 into y1 square plus y2 square plus 5y3 square. So this is called canonical form. Linear transformation, we say x equals to p into y is the linear transformation. We will see that later. Okay, after changing this, when we a changes here it changes to like this: p transpose into a into p. This is p and this will be p transpose. Okay, and the linear transformation is denoted by x equals to p into y. This is called linear transformation. This is called linear transformation. Linear transformation. So let we have an example for this question. Okay, after changing this, we denote this as p transpose into a into p, and the linear transformation is x equals to p into y. Y we will take as y1, y2, y3. X is the variables of the given question, generally x, y, z, or x1, y1, x1, x2, x3. Okay, let me see this with an example. See on the board, reduce the quadratic form to canonical form. Also write the linear transformation, nature, index, and signature. Let us first change the matrix into A matrix. Change the quadratic form into matrix A. You already have done like this. What is here? We have variables x, y, z. X, y, z. X square coefficient is 10, so here it is 10. Y square coefficient is 2. Z square coefficient is 5. Now xy coefficient is minus 4. No, we have to reduce to half. Minus 4 half is minus 2. Xy, no, here it will be minus 2 here, minus 2 here. Xz is minus 10. Xz, so reduce to half, minus 5. Here also xz minus 5. Lastly, this yz is 6. Now reduce to 3, half, 3, 3. So this is the matrix A. Let we write matrix A equals to 10 minus 2 minus 5 minus 2 2 3 minus 5 3 5. So we got this matrix A: 10 minus 2 minus 5 minus 2 2 3 minus 5 3 5. Now how to start? Just now we have written, we have to suppose like this: let A equals to I into A into I. Now the value of A is, we are having 10 minus 2 minus 5 minus 2 2 3 minus 5 3 5 equals to I is, because this is 3 by 3, we have to write 3 by 3 matrix. We have to write 3 by 3 matrix. 1 0 0 0 1 0 0 0 1 into A into again 1 0 0 0 1 0 0 0 1. Now let we start. In first step, let we make this two zeros using 10. Okay, let we first make this two zeros using 10. So I am changing like this. See here, r2 implies multiply with this 5, 5 2s are 10, 5 r2 plus r1, 5 r2 plus r1, 5 2s are 10 minus 10 plus 10 will be 0. In the same way, r3 implies multiply with this 2, 2r3 plus r1, 2 5s are 10 minus 10 plus 10 will become 0. So now let me change this one. Write the first one as it is, 10 minus 2 minus 5, 10 minus 2 minus 5. Now this 5 2s are 10 minus 10 plus 10 0, 5 2s are 10, 10 minus 2 will be 8, 5 3s are 15, 15 minus 5 will be 10. So here you see this one 2 r3, 2 5s are 10 minus 10 plus 10 0, 2 3s are 6, 6 minus 2 4, 2 5s are 10, 10 minus 5 will be 5. So when we are changing the rows, you have to change this one, not this one. So let me change this one, 1 0 0. Now second one is 5 r2 plus r1, 5 r2 plus r1, 5 zeros are 0 plus 1 1, 5 ones are 5, 5 plus 0 5, 5 ones are 5, and 0 0 remains 0 only. Now 2 r3 plus r1, 2 zeros are 0 plus 1 1, both are 0 0, 2 ones are 2 plus 0 2. Now you write the second matrix as it is, 1 0 0 0 1 0 0 0 1. Now next step, we made this two zeros. In the same way we have to make this two zeros, same procedure. This is C2. So C2 implies multiply with this 5, 5 C2 minus, sorry, plus C1 minus 10 plus 10 becomes 0. Now multiply with this with 2, C3 implies 2 C3, 2 C3 plus C1 plus C1. Now let me change this one. Since we are changing columns, you write column. Okay, so this is 10 0 0. 2 5s are 10, 10 minus 10 0, 5 C2, 5 C2 plus C1, 5 8s are 40 plus 0 40, 5 4s are 20 plus 0 20. Now 2 5s are 10 minus 10 0, 2 C3, 2 10s are 20, 20 plus 0 20, 2 5s are 10, 10 plus 0 10. Now we change the columns. Now you change columns, you don't change this matrix, you change this matrix. 1 0 0 1 5 0 1 0 2 into A into, now first columns we are not changing, 1 0 0. Now second column is 5 C2 plus C1, 5 C2 plus C1, 5 zeros are 0 plus 1 1, 5 ones are 5 plus 0 5, 5 0, both are zeros, therefore 0. Now here's 2 zeros are 0 plus 1 1, 2 0 0 0, 2 ones are 2. So we got this one. Now verify, always this two will be transposed to each other. See here, 1 1 1 1 1 1 0 5 0 0 5 0 0 0 2. Always this and this should be transposed to each other. Now first step, second step finish. Now the next step. Now the next step is we have to make this two, this one 0. This is R3. So R3 implies R3, 2R3, 2 into 20 40, 2R3 minus R2, 2R3 minus R2. So let me change this one, 10 0 0 0 40 20. Now if you multiply with this 2 into 0 0, it will remain 0. 2 into 20 40, 40 minus 40 is 0, 2 tens are 20, 20 minus 20 is 0. So we got this one 0. Here also let me change, equals to R1 we are not changing, R2 we are not changing, R3 we are changing 2 R3 minus R2. 2 R3 minus R2. 2 1s are 2. 2 minus 1 1. 2 R3 minus R2. 2 zeros are 0 minus 5 minus 5. 2 2s are 4. 4 minus 0 4 into A. So we have not changed this one. You write 1 1 1 0 5 0 0 0 2. One more step. Let me change. Now the next step is we have to make this one 0. We have to make this one 0. This is C3 no? So C3 implies 2C3 minus C2. 2 into 40 is 40 minus 40 is 0. So let me write this one as it is. 10 0 0 40 0 0. Now change this one. 0 minus 0 will remain 0. 20 minus 22s are 40 minus 40 is 0. These both are 0, so remains 0 in equals. So since we are changing the column, you write this as it is. 1 0 0 1 5 0 1 minus 5 4 into A into. Now see here, we are not changing first column, right as it is. We are not changing second column, right as it is. Now third column is 2C3 minus C2. 2 ones are 2 minus 1 1. 2 zeros are 0 minus 5 minus 5. And 2 twos are 4. 4 minus 0 will be 4. Now watch here. See, this and this will always be transposed to each other. Now one step is left. Let me continue from the top of the board. See here, we can live here itself. We can write like this. This is 10y1 square plus 40y2 square plus 0y3 square. Finish. We can live here itself. But one step I want to change, because in some textbooks they reduce this to 1 1. So last step is very important. If we change this 10 by, we have to change, suppose we are changing this to 1. Suppose I say like this, r1 by 10, then this will become 1, but this will change, this will not change. So this and this will not be transposed to each other. Therefore, to reduce this into 10 into 1, we are write like this. We will write like this. R1 implies R1 by not 10 by root 10. Similarly, C1 implies C1 by root 10. That means we are dividing by, we are writing 10 as root 10 into root 10. Once we are changing by row and once we are changing by column, because we want this to same. The transpose of this should be this one. So in this method, in last step, we will change this to 1. How to change 1? R1 by root 10, C1 by root 10. We can live here itself also, but in some textbooks, they bring these three values to 1. Therefore, I am showing that value, that method. In the same way, R2 implies. Now this we have to change to 40. 40 to 1. So divide by root 40. R2 by root 40. And similarly, C2 implies C2 by root 40. So this is the method. So this will become, when we divide by root 10, this will become 1 0 0 0 1 0 0 0 1. So how this will change? Now we are dividing R1 by root 10. So divide R1 by root 10. So this will be 1 by root 10 0 0. Divide R2 by root 40. So this will be 1 by root 40 5 by root 40 0. We are not changing this one. 1 minus 5 4 into A into C. Here first column we are dividing by root 10. So divide this by 1 root 10. 1 by root 10 0 0. This by root 40. So this will be 1 by root 40 5 by root 40, and this is 0. We are not changing this one. 1 minus 5 4. Now this is of the form like this. See here, diagonal matrix. This is diagonal. So this is of the form D equals to, we suppose like this, P transpose into A into P. Therefore, you see here some steps are there. First is canonical form. Sorry, here we are having 0. Canonical form. Canonical form equals to, you apply with this y1 square, with this y2 square, with this y3 square. So y1 square plus y2 square, this becomes 0. Leave this one, first step. And second step is, what is P here? This is P transpose, this is P. So I'm writing just P. We are having P value as, so I write here Well, we are having p equals to 1 by root 10, 1 by root 10, 1, 0, 5 by root 40, minus 5, 0, 0, 4. This is p. Okay, next step, you see, one after one. Now let me see the next steps. This is, now what is the index here? Question in index means number of positive terms, 1, 2. Two numbers are positive, so 2. Next one is what are the variables here? Number of variables we are having 3, x, y, z. Now rank r equals to, see here, we are having only rank 2. Watch carefully. Here we are having 1, 1, 0. Because this is 0, the rank is only 2. The rank is only 2. So what is the condition here? If you see the condition here, see here, we say like this, r is less than n and s equals to r. We wrote this condition in the last class. This is what? Semi-positive definite. This we call semi-positive definite. Semi-positive definite. Nature is semi-positive definite. Nature is semi-positive definite. And nature, sorry, index is 2, that is number of positive terms, both are positive, therefore 2. Number of variables 3, rank is 2. One more question, two more things are left in the question, and the next one is signature. We wrote the formula of signature. The formula of signature is 2s minus r. So 2 into s is 2 minus r is 2. 2s minus r, so 2 2s are 4, 4 minus 2 is 2. So the signature is 2s minus r. 2 into 2 minus r is 2. So this will be 4 minus 2 is 2. And the last one is linear transformation. Linear transformation. Linear transformation, the formula is Vx equals to p into y. X equals to p into y. What is the x here? Variables x, y, z. X, y, z equals to p. The value of p is here we are having 1 by root 10, 1 by root 10, 1, 0, 5 by root 10, minus 5, 0, 0, 4 into linear transformation into y. Y we have taken y1, y2, y3. So this is called linear transformation. X equals to p into y. X equals to p into y. See, here is a little mistake here. We wrote here, see here, p value 1 by root 10, 1 by root 40. This is actually 1 by root 40. Okay, let me change this one. And the remaining is same. So this is 1 by root 40. So just you change this one, 1 by root 40. This is. And the next thing is, we call this as positive semi-definite. This is positive semi-definite. Positive semi-definite. So this is the question we have done. Transformation to canonical form by using diagonalization method. This is called diagonalization method. Inshallah, in the next class we will continue, inshallah, by the method of reduction method, inshallah, in the next class. So I request you to share my this videos and like this videos and also subscribe these videos. Inshallah, we will continue in the next class.